Hello everyone and welcome to my channel. So today we have this question. We are being given two statements. Statement 1 says the first ionization enthalpy of the elements sodium, magnesium, chlorine and argon follows the order. Sodium is greater than magnesium, magnesium is greater than chlorine and chlorine is greater than argon. And the second statement says among calcium, aluminium, iron and boron, the third ionization enthalpy is very high for calcium. Okay, so we have to analyze these two statements and we have to answer that which one of these is correct, or both of these are correct, or maybe both of these are false statements. If you have read about periodic trends and periodic properties, then this question is based on the property of ionization enthalpy. So first of all, what is ionization enthalpy? So ionization enthalpy is the amount of energy that is needed to pull the outermost electron of an isolated gaseous atom in its ground state. So this is kind of a very bookish definition. So in simple words, it's the amount of energy that is required to remove the outermost electron of an atom in its ground state. So let us suppose that this is the outermost electron of any particular atom and this has to be removed. Okay, and then we get a cation. From neutral atom we get a cation after the removal of the electron. So this amount of energy that is required to pull that electron out and form the cation, that energy is the ionization energy or ionization enthalpy. So this process is endothermic because we require the energy. The energy is given. It is not released, but the energy is required. So that means we have to give the energy to pull that electron from its outermost shell. And what about the periodic trends? So the periodic trend says ionization energy increases across a period. So as we move from left to right, so across a period means we move from left to right in a periodic table across a period, then ionization energy increases, while ionization energy decreases when we move down a particular group from top to bottom. Okay, it decreases down the group. Now what is the reason why it increases across a period? So we very well know that across a period, size, the atomic or the ionic size decreases. Okay, and also we very well know that across a period nuclear charge increases. So what happens if you have this background knowledge that why the atomic or the ionic size decreases across a period? Although the number of electrons also increase when we move from left to right across a period, but the increase in the nuclear charge is much higher as compared to the number of electrons that are increasing. The number of electrons, they remain mostly in the same shell, okay, when we move across a period. But the nuclear charge increases a lot as we move from one element to another from left to right. Okay, so nuclear charge, the increase in the nuclear charge is much more significant factor as compared to the increase in the number of electrons. And this increase in the nuclear charge pulls the electrons more towards itself, and therefore the size decreases. The atomic or ionic size decreases. Now, when it is clear that across the period the atomic or ionic size decreases, then what happens to the ionization enthalpy? Now I have drawn a small diagram to make you understand. So in the first case, you can see we have a particular atomic or ionic size, and this atomic or ionic size decreases from second to third stage. Okay, that means we are trying to show that size decreases across a period as we go from left to right in a period. Okay, the horizontal lines, you already know the horizontal lines of a periodic table is the period. Okay, so as we move horizontally from left to right, the size decreases. Now what happens when the size decreases? So you can see the outermost electron I have indicated here. The outermost electron is attracted by the positively charged nucleus. And as the size decreases, this outermost electron is getting closer and closer to the nucleus because of the decrease in the size. That means the nuclear pull is much more effective, and the nucleus, the positively charged nucleus, attracts the outermost electrons more strongly as we move from left to right. Okay, so what is the result of this? So that means to pull out an electron from stage 1 will be much easier, than to pull out an electron in stage 3, because it is more attracted. Stage 3 electron, outermost electron, is more attracted towards the nucleus because of the small size. So to remove this electron in stage 3, which is more attracted towards the nucleus because of the small size, the nuclear pull is very high. So that means when the removal of the outermost electron is difficult, that means we have to apply more and more energy to pull that outermost electron. What happens in stage 3? In stage 3, the ionization energy is higher as compared to the ionization energy in stage 1. So stage 1 ionization energy is lower. The ionization energy increases from left to right in a period. Okay, so after understanding all of these, let's analyze statement 1. So statement 1 says the first ionization enthalpy of the elements sodium, magnesium, chlorine and argon follows the order this. So it says that sodium has very high ionization energy as compared to argon. So from sodium to argon, you can see here, if we move from sodium to magnesium to chlorine to argon. So what we are doing, we are moving across a period. All these elements are in the third period. You can go back and check your periodic table. All of these are in the third period. So these are the third period elements. So we are moving across a period from left to right. What we discussed just now, that as we move from left to right, the size decreases, the nuclear pull increases, and it is very difficult to pull out the outermost electron as we move from left to right. That means ionization energy increases. So as we move from left to right, the ionization enthalpy should increase. So the actual order of ionization enthalpy among these elements should be something like this. So sodium should be less than magnesium, should be less than chlorine, and should be less than argon. Sodium should have the least ionization enthalpy, okay, while argon should have the highest ionization enthalpy. It is very logical also. Argon is a noble gas and it has a very satisfied octet, and to pull an electron from that very stable element will be quite a difficult task. So the order should be sodium is less than magnesium, is less than chlorine, is less than argon, and not the given order. Sodium is greater than magnesium is greater. No, this order is wrong. So statement 1 is false. Now let's go to statement 2. Statement 2 says that among calcium, aluminium, iron and boron, the third ionization enthalpy is very high for calcium. Now for knowing the third ionization enthalpy, the trend for third ionization enthalpy, we need to get the electronic configuration of these elements. We have to analyze that. Then only we can reach to a conclusion that whether the third ionization enthalpy is highest for calcium or not. And first, second and third ionization enthalpy means consecutively when we pull out one electron after another. So first ionization enthalpy is pulling the first outermost electron. Then whatever is remaining, the second outermost electron. Then the third outermost electron, whatever is remaining after pulling out the second. So consecutive removal of the outermost electrons gives us the first, second and third ionization enthalpies. Okay, so let's write the configuration of calcium. Okay, so I have written all the electronic configuration for these elements. So let's see the third ionization enthalpy. So you can see here we have 3p6 4s2 for calcium. Okay, so if we remove the first and second outermost electron, that is from the 4s subshell, then we get 3p6. If first and second are removed, then we have 3p6. So 3p6 means the P shell is completely filled after the second ionization is done. So this is the situation after second ionization. Now for third ionization, we have to pull an electron from the completely filled p orbital. And this task of removing this particular electron from the fully filled p orbital is a difficult task. So this ionization enthalpy will be very high. That means we have to give very high energy to pull this p6, one of the electrons from the fully filled p orbital. So this has to be a very high ionization enthalpy. Now what happens in case of aluminium? In case of aluminium, we have P1. So first ionization energy will be done after removing the P electron, 3P electron. Then second and third ionization energy after removing the 2, 3s electrons. So this electron and this electron removal will give us the third ionization enthalpy, which is not very difficult, because after we remove the 3s2 3p1 we get a completely filled 2p6 orbital, and here we do not have a very high ionization enthalpy. Okay, it won't be very difficult to remove the p1, and if one of the s is removed after second ionization, removing the third electron is also not a very difficult task. So this aluminium third ionization enthalpy will not be very high. Then boron also p1, if p1 is removed, s2 is removed, then we have only one s2, which is quite a stable configuration. So for boron also, the third ionization enthalpy should not be very high. Then what about iron? So for iron, we have to remove 4s2, 2 electrons of the 4s orbital. So 2 removed, and then we are left with 3d6. If we remove the 6th electron, okay, this one. If we remove this electron, then we are left with the D5 configuration. And this D5 configuration is quite stable configuration, okay, because it is half filled d orbital. So the third ionization enthalpy for iron is also not very high, because after third ionization, it gives us the stable half-filled 3d5 electronic configuration. So what we are left with? We are left with only one very high ionization enthalpy, that is for calcium, because in case of calcium, after the second ionization, we have a fully filled p6 orbital, and which is very stable, and pulling this electron from this very stable configuration is a very difficult task, where we have to apply very high amounts of energy. So that is why the third ionization enthalpy for calcium is very, very high. And statement 2 says the same thing, that among calcium, aluminium, iron and boron, the third ionization enthalpy is very high for calcium. Yes, statement 2 is correct. Statement 1 is false. Statement 2 is correct. So let's find that option. Statement 1 is false, but statement 2 is true. Okay, so last option, the fourth option will be our correct answer, which says that statement 1 is false, statement 2 is true. So I hope you understood this explanation, and if you like my videos, please do not forget to like, share and subscribe. And till then, keep learning, keep watching, and see you soon with the next problem.